Okay, here's the next one. I usually write this as the third property and rather than the second, but that's your book uses it as the second property. It says b to the x to the y power. This is the property of exponents. Is b to the x times y. The property of logarithm says if I have log base a of m to the k, I can bring the k down in front, so it's k log base a of m. Now what makes it so difficult, because if I look at the property of exponents, that's associated with, it says I'm multiplying the two exponents. Well, theoretically speaking, log base a of m is an exponent. K was an exponent that I brought down in front. This is the product of two exponents. Now, do I ever think about that when I do the problem? No. One thing that for me with working with the properties of logarithms, I didn't really understand until I actually had to teach the stuff. But I could work with it. And that's when you'll learn it, when you have to teach it or explain it to somebody else, quite honestly. So if I were going to use property 2, it says log base a of 9 to the negative 5. You're going to bring the negative 5 down in front, and that's log base a of 9. That's it. Now, this is where we get ourselves into trouble. As you notice, this next one example is a radical, and the log base a of the 4th root of 5. I first have to write the 4th root of 5 as an exponent, so it's log base a of 5 to the 1/4. Now you can bring the exponent down in front, and it's 1/4 log base a of 5. That's going to be the trick, is when you're dealing with radicals. So here we go. Log base 9 of x to the 7th. I can bring the 7 down in front. This is 7 log base 9 of x, and that's all you need to do with that. I'm going to have to take this guy and rewrite him. This is the natural log of x to the 1/7 power. And that's a rewrite. Now I can use property 3. This is 1/7 natural log of x. This is where I need my white tape. Unfortunately, this is the one that's going to have to go up on YouTube until I redo it this summer. This would be natural log of x. That looks better. I forgot to video it in 8 o'clock hour, so this page wasn't done. And now we're going to combine the two properties that we have, property 1 and property 2. And this is the log of xy cubed. Now, that's the argument is xy cubed. I notice what I have is a product. This is really the log base b of x multiplied times y cubed. The only thing being cubed is y. X has an exponent of 1. If I wanted both of them cubed, I'd have to have x and y in a set of parentheses. Now, using property 1, this becomes log base b of the first factor added to log base b of the second. So that's property 1. And then I can bring the 3 down because he has an exponent of y cubed. This would be log base b of x plus 3 log base b of y. And then that's as far as I can take it. The exponents on x and y is 1, which is what you're headed toward. And this would be property 2. Now, in this instance, I noticed that both x and y are under the square root, and so as a result, that's the radicand. So I need to rewrite this problem as the natural log of what's under that radical to the 1/2 power. And what's under the radical is just x and y. Now, this is where we're getting onto the edge of college algebra now, because the problem can be a little tricky if you're not careful. Because property 3 says I can bring the exponent down in front, so this is 1/2 natural log of x times y, so I got rid of the exponent. But unfortunately, this is 1/2 times whatever this becomes. So when I go to rewrite this, that says it's 1/2 times this guy expanded. And since this is a product turns into a plus, a sum. This is the natural log of x plus natural log of y. This here is property 3, and I just used property 1. Now, I could leave this as an answer. That would be no problem. Or I could distribute the 1/2 through, and that still would be an acceptable answer.
Plus 1/2. So we can do the 1/2 from the beginning for each one and just...
Yes. Yes. Correct. Yeah. Absolutely. And there are times I actually do that because it makes life easier. Yeah.